So Karen wants to go to Mars. Bob and Andy want to put a payload on the moon. No one's going nowhere without a rocket. Until a filament of graphene 62 miles high will achieve the space elevator, this guy has the secret to space exploration. This is Jeff Greason. Thank you for coming all this way.
It was our pleasure.
Thank you.
Well, the secret is there is no secret. I'll come back to that. Some of you of a certain age, this age, will remember that there was a time that the previous speakers have spoken about when we didn't just, think that maybe someday it would happen, but we actually thought we would live in it. We would live in the day when we were going to open a limitless new frontier that was going to keep mankind busy for a few thousand years at least. Those of you who are not of that age may not realize that if you wonder why you seem to be living in a world where, in spite of everything being better than it has been at any time we have any record of, you are constantly being told that everything is awful, it's because you're living in a world run by people who all thought we were going to get that frontier and saw it taken away from us. But frontiers are not opened by people who are faint of heart, as was pointed out previously. They are opened by people who don't care if they try and fail and don't care if they try and die. The first 3 colonies in Canada all failed. The first 3 colonies in Los Angeles all starved to death. The people keep coming. And there are those of us out here who were not going to let a little thing like the failure of a government program to continue stop us from going to space. So I want to say a few things about why go, because it's things that we who think about space all the time know so deeply we don't talk about it. And I don't think that everybody out in the rest of the world really gets it. There's this feeling that we went to the moon and we stopped, so how interesting could it have been? The answer was incredibly interesting. But there was a long pause between things like Leif Erikson and Christopher Columbus and any actual economic use by Europeans of the North American continent. And there's been a much shorter pause since the discoveries of Apollo and all the unmanned space exploration that have followed. But we have found a lot of interesting things, little things. There is more energy up there than even people like me who juggle numbers for a living can really wrap their heads around. We worry about trivial little energy crises here on Earth. Even if you count up not just the energy that human beings use, but all the energy used by all the living organisms on the Earth, and compare that to the amount of energy we can get out there in the solar system, it is on the order of 700 billion Earth's worth. We are in no danger of running out of anything. About 1% of that, only a couple billion Earth's worth, is in the form of magnetic energy speeding through space that you can pick up by throwing out a loop of wire. Yes, it's a big loop of wire, but there's lots of room out there. There is stuff up there in space, stuff that some of us down here occasionally like to get. I won't read the bullets, but we could bring back one asteroid every 10 years or so, a small one, render it down to platinum group metals, and that would flood the world market 10 times over for all the platinum group metals that we can get. Now, the money people, who I'm not one of, get very excited about the fact that you're bringing down platinum by the ton. That would be nice. The engineers, which I am one of, get more excited about the fact that we know all kinds of engineering uses of things to do with platinum group metals, like higher efficiency engines, that we don't do because the platinum's too expensive. Wouldn't it be great if platinum were cheap? That could happen if we stop thinking about this planet as the only one that we can get resources from. And there is, as the people like to think of, real estate. The moon's been talked about already. It's about the size of Africa, and thanks to the recent discoveries of water and other volatiles at the poles, conservatively, you can figure out how to hold about 10 million people up there, the size of a fairly significant city. It might be a lot more, but that's just based on what we know about right now. Whoops. Mars, which I have done incorrectly. There we go. Mars has a land area comparable to Earth. If we warm it up a couple of degrees, some of that land will be covered by water, which would only leave you with something the size of North America, Europe, and Asia combined. Only a modest-sized planet. And if that's not enough for you, If you look at the asteroid belt, which is essentially a planet broken up into bite-sized chunks, and look at disassembling that for habitat volume, where you live on the insides of things instead of on the surface of things, you can find room sufficient for about 20 billion more people. If you want to look instead at the entire resources of the solar system, the limiting factor becomes how much nitrogen you can get. That's a little scarce in the inner solar system, but quite abundant in the outer solar system, so you actually have to trade for things. You start looking at a limiting carrying capacity of the solar system of about 1 trillion people. And of course, this is not the only solar system out there. So all of the things that we thought were true back in the 60s of how limitless our future could be are true. We just haven't gone out and gotten it yet. Unfortunately, what's holding us back is one factor, which is the cost of launch specifically. There's a lot of other pieces that have to happen, but they're comparatively straightforward. The launch cost is what's been the big bugaboo. So I want to talk a little bit about why that is what it is. And I start with the markets for launch. We've talked about some of them. Returning materials from asteroids. You could think about that or from the moon. You could think about that maybe being cost effective just barely now. If you start dropping the cost of launch to about hundreds of dollars a pound, which is about a 10-fold reduction from where it is right now, it becomes obviously possible to put the business case together to do that. Solar power can be gotten in space and it doesn't get dark up there. Well, some would say it's always dark. The advantage that has is that the power is available 24/7. Whether that is or isn't going to become economically practical is something that people debate. But if it is going to be economically practical, it becomes economically practical at something on the order of $400 or $500 a pound of launch to West to orbit. And then there are colonists, like my predecessor, people who want to go because they want to go. And for people who are in the trucking business, like me, we don't really care why you want to go, as long as you have the money to go. People don't think of colonization and things like that as a business, but if you look historically, it is. People did not send colonists to the New World for fun. The people who ran the ships or bought the ships or sold the ships got paid. Colonists for past efforts take on the order of hundreds to maybe a few thousand people to establish a viable colony. It doesn't take millions. And there are many more people and a much larger economy on the Earth today than there were hundreds of years ago when most of the past colonization efforts that we have records of were established. So if you think about that in terms of the fraction of the gross domestic product of the society that was being sent, if we could get the cost of a colony down to something like $50 or $100 million per colonist, it becomes comparable in cost in terms of the fraction of the GDP of the society to past colonization efforts. Yes, that would mean it would be a $10 billion effort or so to plant a colony, but do you really doubt that if we could get the cost of establishing a true colony on Mars or on the moon down to $10 billion, that whether it be from government or private sources or a combination of that, we couldn't find the money? I'm sure we could find the money, or somebody could find the money. This is a little bit technical, but it's the core of understanding what's holding launch back, so I want to take a couple minutes to talk about it. The graph on the left is the relationship between what the projected cost of launch and what the projected volume of launch would be. So, of course, the cheaper launch gets, the more people do it. But what you notice is the line's not straight. And if you cut the cost of launch in half, the question becomes, do people launch more than twice as much stuff? And at the current price, the answer is pretty much no. And the reason is that the only activities that are going on in space right now are activities where people almost don't care what it costs. A communication satellite is essentially a license to print money. There are only so many slots, there's only so many countries that need communication satellite services. Whoever gets the slot and gets the contract can pretty much print money with that satellite for a long, long time. So they really don't care what it costs to launch. But because of that, it's like any other extreme luxury product. The same thing would appeal if I talked about ultra high-end business jets. If you cut the cost of those in half, would you sell twice as many of them? No. What about ultra high-end luxury yachts? Same thing. They sell the number they have because that's the number of people who are willing to buy something that don't care what it costs. That's not true forever. As you start getting down below a certain threshold price, which in my own estimate is somewhere in the hundreds of dollars a pound range, new markets start to open up that are very cost sensitive. Taking people, recovering minerals, taking groceries up to and from space stations where people are staying, that kind of thing. So if you multiply the volume of launch being done by the cost of launch, you get the revenue that is available to service the launch industry. And that's the graph on the right, which I've done for American providers, but I could scale it by a factor and get to world providers. And you see that that curve has a dip in it. And that dip reflects the fact that when the cost is very high, a small reduction in price doesn't result in a comparable increase in volume. But when the cost gets more low, the volume starts to pick up more than fast enough. So think about what it's like to be in a market where the cheaper the product is, the less money you make. People are creative. They think of lots of reasons why the product should be expensive. That's the only way they can make more money. So they want to sell you the leather interior and the custom feature, and we have a lot of hand-holding services and a lot of value-added things, a lot of consulting, and that's the way the launch business is today. When you're in a business where the cheaper things get, the more money you make, like cell phones or computers, all of a sudden there's a tremendous rush of ingenuity on how can people figure out how to make things cheaper, because that's the way you make more money. And this step in between is what I call the valley of death in space launch economics. Until we get enough cheaper that we get into the region of positive demand elasticity, things are not going to change. But once we get enough cheaper that we're in that region, things will never change back, because it will always be more cost effective for somebody, new competitor, to come in and figure out a way to do an even cheaper launch and therefore make more money. People like to make money. So how you get the cost down to that point? You have to reuse the ship. To scale, that's the Soyuz rocket and a 747. They cost about the same to buy, actually. In fact, the Soyuz is quite a bit cheaper. But you get about 10,000 uses out of the 747, and you get one use out of the Soyuz. And that's the reason why air travel is cheap and space travel has been expensive. This is not new news, by the way. People have realized this since the 40s. But it's hard to figure out how to do reusable launch. So we started on a very small scale. We took an existing aircraft, developed reusable rocket engines that didn't wear out and didn't take 500 people with German accents and white coats to maintain all the time. Our projections were that we could get a reusable rocket vehicle of very low performance, but still reusable, manned, that we could fly for about $5,000 per flight. By the end of its flight test program, oh, we actually do have sound, except we have no video. By the end of its test program, we had it down to $900 per flight for a manned rocket, which is about 5 orders of magnitude less than anybody had actually demonstrated before. Our next project was more focused on the speed of turnaround. How many flights per day can we get out of a ship? Because obviously the more flights per day you get, the more money you can make. That became the X-Racer, which we did for an outside customer. This was a fun ride. I was on the right seat on this for one of the test flights. Our test pilot on this program and for the next program is Rick Searfoss. He flew the space shuttle 3 times. There's an awful lot of ex-shuttle jockeys who like the pilot spacecraft approach that we're taking. There's a myth, by the way, that fuel cost is a reason why you can't have cheap space launch. I just wanted to dispose of that quickly. Even for going to orbit, the cost of the fuel and oxidizer that you use is on the order of about $30 a pound. So it's absolutely not a limiting factor. It's the cost of the ship and the cost of the labor to turn the ship around between flights that dominates the cost of space launch. So our next step is suborbital flight. We are moving towards an orbital system, but we have to take it step by step. Because we don't have a billionaire writing checks for us. And it probably is a good thing we don't have a billionaire writing checks for us, because that would enable us to hire a lot of people, and then we need a lot of money. And it's, as I sometimes say, hard to figure out how to make things cheaper by spending a lot of money. Suborbital flight is essentially halfway to orbit in terms of difficulty of building the ship. If you can do a suborbital flight in one stage without a carrier airplane, you can put two of them together, technologically speaking, not of the same ship, but of the same technology, and you have an orbital system under your belt, and that's the step that we're working towards. There's the only computer animation I'm going to show, because it's still being built, but here's the concept of operations for the suborbital vehicle, which is also very small. You burn the engines for about 3 minutes, up to about 180,000 feet, and then it coasts up to about 350,000 feet, or about 100 kilometers. Or about 10 times higher than an airliner flies. Orbit next, but we got to get this flying first. I want to say a few words about why it can be done for a very low amount of development money compared to what you may be thinking. By starting with reusability first and focusing on a very quick turnaround and small number of maintenance man-hours per flight, each experiment that we take is very quick. If we have a problem or we have a change we want to make, we just make it, and then we go out and fly again the next day and try the change out. That's enormously cheaper than it is to start by developing a high-performance vehicle and then trying to figure out how to make it cheap and reliable to operate. And for that reason, this is being funded mostly through the investment of ordinary people, doctors and dentists. You probably know people who can write the kind of checks that we are using to fund this vehicle. Our total investment to date is on the order of $30 million, not counting revenue that we brought in from various sources. And so just a couple of quick progress charts. I'm over time, so I'll be quick. There's the cockpit and the forward windscreen under construction. That's the wing spar carry-through and the fuselage, which just had the LOX tank buttoned up in it. And there's the engines firing. We've been running them for a couple of years now. We developed the engines and the engine technology and all of the affiliated systems so that this thing can be reused over and over again. I really don't know what the wear-out life is, but I know it's more than 2,000 firings. One of these days we'll wear one out, and then I'll have some idea what the life is. And with that, I just want to close by saying, as one of my previous speakers said, space is not something that you have to stand back and hope and wonder whether it will happen someday. I was just somebody working at Intel who got tired of waiting, and I wanted to dive in and see if I could do something to help make it happen. I didn't think I was going to be running a company. I just wanted to work for one. But they drafted me essentially to be CEO. And if you don't have the right technical skills to do that, you or somebody you know can probably invest enough to actually make a difference. And if you care about this stuff, or whatever it is that you care about, don't just wait back and complain that it's not happening. Go out and make it happen one way or the other. And with that, I will close. Thank you.
So, Jeff, are you bidding on our business? Do you want Moon Express business?
I'm more likely to supply propulsion for your later generation vehicles.
Later generation. So who's going to get us up there on the first try?
I don't think we'll be ready in time. I think your first ship will be ready before we're ready to take you to orbit.
How many other companies are there developing the thrust?
There's really no other, there's not very many companies that are in the propulsion end of the business. There's 2 or 3 other companies that are doing suborbital vehicles, and of those, 1 or 2 that have serious plans to go forward to orbit.
So our choice at Moon Express is fairly limited, right?
Yes, at the moment.
At the moment.
But we're changing it as fast as we can.
Boy, thank you so much.
Thank you so much.
Yeah. One more.